Bismillah ar-Rahman ar-Rahim. Good morning everybody. Today inshallah I'll explain to you chapter 18 chemical tests. Chapter 18 chemical tests in your book page 190. Inshallah when I finish this chapter, it is the last chapter in this academic term inshallah, and I'll start to solve or answer the questions with you, and also I'll revise lesson by lesson inshallah and make focus on the important points. Today inshallah I'll talk about chemical tests. Chemical tests for what? Chemical tests for detecting a presence of a special gas. We want to testing for gases like hydrogen, like oxygen, like carbon dioxide, like ammonia, and I think that you took this tests in grade 7. Okay, testing for gases. If I want to test the presence of hydrogen, I'll use a lighted splint, and this lighted splint, when I put it near to the mouth of the test tube contain hydrogen, I'll hear the hydrogen explodes with squeezy pop. So to test the presence of hydrogen gas by using lighted splint, and the hydrogen explodes with squeaky pop. I'm sorry. Okay, and to test hydrogen, we will use glowing splint. Oxygen relights glowing splint. If the gas I tested is oxygen, by using a glowing splint, it relights a glowing splint. And the test for carbon dioxide gas. Carbon dioxide gas is bubbled through limestone. The carbon dioxide turn limestone milky, turn limestone cloudy, turbid, like this, due to formation of calcium carbonate. You have to know that limestone is calcium hydroxide, and when I pass it over carbon dioxide, it will produce calcium carbonate, which is milky. Let's see here. Open your book with me, page 191. Testing for gases. Testing for gases, please make highlight over what you see. Testing for hydrogen gas by using lighted splint. Squeaky pop. A lighted splint is held to the mouth of the tube. The hydrogen explodes with a squeaky pop. As you see here, hydrogen and oxygen produce water. I want from you to know the name of the gas, what is the thing I use it to test it, and what is the result of the test, a positive result. In case of oxygen, I use glowing splint. Make highlight over glowing splint. The oxygen relights a glowing splint. So I want from you to make highlight over hydrogen using a lighted splint. Squeaky pop. Highlight over oxygen using a glowing splint. The result relights glowing splint. In case of carbon dioxide, change limestone milky or turbid or cloudy. I want from you to know that limestone is calcium hydroxide. With carbon dioxide, change into milky, which is marble chips, calcium carbonate. And to test the presence of chlorine, and as you know that chlorine is a green gas. Like this. To test the presence of chlorine, I use a piece of damp litmus paper or universal indicator paper. I think you took it in grade 7, is to use damp litmus paper. Okay, I put it in the tube contain the chlorine gas, which is green gas. The result of the test is a positive result, indicate to me that I have chlorine gas, that the gas bleaches or turns white the damp litmus paper or universal indicator. Okay, like this. Bleach, remove the color. So testing gases, testing hydrogen by lighted splint, squeaky pop. Testing oxygen by glowing splint, realize a glowing splint. Testing carbon dioxide by using limestone, change it into milky or cloudy or chalk اللي هو الكالسيوم كربونيت marble chips. And to test the presence of chlorine gas, we use a piece of damp litmus paper or universal indicator. What happened? Chlorine is a green gas that bleach the damp litmus paper or universal indicator, as you see here. Okay, in the last chapter I talked with you about the salts, and I said to you, okay, we have another gas which is ammonia gas. Open your book with me in page 192. Ammonia gas. How I can test the presence of ammonia gas? You can test the presence of ammonia gas from its smell of ammonia, okay? Or hold a piece of damp universal indicator paper or red litmus at the mouth of the test tube containing ammonia. The ammonia turn universal indicator paper or litmus paper into blue. So the test for ammonia gas by smelling. You will smell ammonia, or using damp litmus paper, which is red, okay, red litmus paper, and make it close to the mouth of the test tube contain the ammonia. It will turn the paper blue. Okay. Testing for water. If I want to test the presence of water in thing or in compound, okay, we will use, and this I explained it to you, or just give it as a notification when I explained the last lesson, when we prepare the copper sulfate crystal. I said to you the copper sulfate itself is white, and with water it will be hydrate, without water anhydrous. And I said to you take care from this word or this term and its definition. Anhydrous, without water. So anhydrous copper sulfate is CuSO4, which is white in color. With water, and when make water of crystallization, you have another formula, CuSO4 with 5 molecules of water that are chemically connected with the copper sulfate, 5 molecules of water, and we call it hydrate copper sulfate. This hydrate copper sulfate is blue in color. So important, testing for water by using anhydrous copper sulfate to change anhydrous copper sulfate, which is white, to change it into blue hydrate copper sulfate or hydrated copper sulfate, as you see here. Okay. Of course, you know that a salt contains positive ions and negative ions. Any salt contains positive ions and negative ions. And we start to name the salt by saying the positive ions first and then the negative ions. Okay? So any salt contains positive ions and negative ions. Okay. Today I'll explain to you how we can testing for ions Which kind of ions? Especially positive ions. Especially positive ions. Make highlight around a salt contain at least one cation. Cation is positive ions. And anion, negative ion. Okay, please, I want from you to know this term. Cation, positive ions. Anion, negative ions. Okay, today I'll test presence of cations or positive ions. We have two kinds of tests. One of these tests, what we call flame test. Make highlight around the flame test. Flame test, how I can make this flame test? I use a platinum loop. The loop, I use it in the lab and put it in an acid, then burn it on the flame. Dip this loop in the salt you want to test the positive ion on it and put it on the flame. You will find different colors for this flame. Each color explains to you a positive cation or positive ion. Like here, I want from you to know that in case of flame test, I detect the presence of cations, positive ions. Like here, look. Important, memorize them. Important, important. Okay. If the salt contains litmus ion, all of the cations are metals. If the salt contains litmus ion, as you see, the flame color will be red. If the salt contains sodium ion, the flame color will be yellow. If the salt contains potassium ion, it will be lilac in color. Lilac. If the salt contains calcium ions, the flame will change into orange color. And if the salt contains copper ions, it will give green flame. Important, and you must memorize them. Okay? So, to detect the presence of positive ions, I'll use number one, flame test. Flame test, I can use it to detect certain kinds of ions, positive ions, cations, like lithium, which give red flame, like sodium, which give yellow flame, like potassium, which give lilac flame, like calcium, which give orange flame, and copper, which give green flame. Okay, of course you know that the lithium carry one positive charge, so the lithium ion is Li1 plus, sodium Na1 plus, potassium K1 plus, calcium Ca2 plus, and copper Cu2 plus. Okay, I think it's easy to memorize these only by using what I test the cations by flame test. What are the colors of the positive cations, positive ions? As you see here, memorize them well, please. I can ask you in the form of table. Some kinds of positive ions, I can't detect them by using a flame test, but I use another test, testing for cations, positive ions, using sodium hydroxide solution. Sodium hydroxide solution. So, how I can make this test? I'll make a solution from the salt I want to detect which kind of positive ion contain in this salt, and add to it few drops from sodium hydroxide. Why especially sodium hydroxide? Do you remember from the last chapter that most of hydroxide are insoluble? Most of hydroxide are insoluble, except what? Except sodium, potassium, and ammonium. And already I can test the presence of sodium by using a flame test, and lithium by using a flame test. Okay, potassium by using a flame test. So here Other cations, I can add sodium hydroxide solution to the solution of the salt I want to detect which positive ion in this salt, or which positive ion the salt contains. Okay, I'll add the same amount from the solution of the salt I want to test it, and the same amount from sodium hydroxide. Why especially sodium hydroxide? Because most metal hydroxides are insoluble. Most metal hydroxides are insoluble. This is why question. When I ask you why especially we use sodium hydroxide to test the presence of cations, you tell me that most hydroxides, metal hydroxides, are insoluble. So, insoluble, so give me precipitate with different colors, okay? And according to the color of this precipitate, I can detect which cation I have in my testing salt. What I want from you from this part, I want this table. Now I am in page 194. This table, as you see, summary of reaction of positive ions with sodium hydroxide solution. Important. Here, if I have copper 2 positive, so copper I can use flame test, give me green, or by using sodium hydroxide, it will give me blue precipitate. Blue precipitate from what? From copper hydroxide. And as you know, hydroxide, most hydroxides are insoluble. What is the formula of copper hydroxide? CuOH, all 2, because as you know, OH is 1 negative and Cu2 positive, and exchange the charge. Second, take care from this point, please. We have 2 kinds of iron, Fe2 and Fe3. Important. Fe2, if I have a solution from salt contain Fe2 ions and add to it sodium hydroxide, it will give me green precipitate. Green precipitate from what? From iron hydroxide. Take care, iron 2, the formula will be FeOH, all 2. And we have iron 3. If my salt, I want to test the presence of iron 3 in it, add to it solution of sodium hydroxide, it will give me orange brown precipitate from iron hydroxide also, but in this case it's FeO3 OH all 3. As I said to you, we have ferrous and ferric. Ammonia, if the salt contain ammonia, I can detect it by adding sodium hydroxide. It will give me no precipitation. So take care from this table, please. Okay? So again, what I want from you in this chapter, in the beginning, I want from you to know, in page 191, how I can test the presence of hydrogen, how I can test the presence of oxygen, presence of carbon dioxide, presence of chlorine gas, and the presence of ammonia gas. Okay? And then how I can testing for water by using anhydrous copper sulfate, which is white CuSO4. With water, it will change into blue hydrated copper sulfate crystallization, water of crystallization. Memorize well the formula. Okay, this is the blue color. And to testing for ions, if I want to test, as you know, that all salts contain cations and anions. To test the positive ions, metals, I use flame test. What are the colors of the flame test? As you see here in page 193. Important, and I can ask in the form of table. And also I can use sodium hydroxide to test the presence of cations, because most sodium hydroxide, metal hydroxide, because most of metal hydroxide are insoluble. So when I make a solution from the test, I want to detect presence of positive ions on it and add to it sodium hydroxide solution, it will give me precipitate. And according to the color of this precipitate, I can detect which kind of ion I have. This table summarizes all things. If the salt contains copper ions and add to it solution of sodium hydroxide, it will give blue precipitate from copper hydroxide, which is CuOHO2. If the salt contains iron 2 and add to it sodium hydroxide, it will give you green precipitate from iron hydroxide, FeOHO2. If the salt contains iron 3 positive, it will give me orange brown precipitate from iron hydroxide, FeOH3. And if the salt contains ammonia or presence of ammonia gas with sodium hydroxide, no precipitate. Okay, this all things I want to test the presence of gases, water, cations in your book and in the guidebook. Open your guidebook with me, please. You will find a test for ions and gases in the guidebook, chapter 16, not 18. Okay, I want this table in page 54. Your guidebook, page 54. I want this yellow table. As you see, lithium give red color, potassium مع الفليم تيست potassium lilac, calcium brick red. اوكي، او هنا كاتب في الكتاب بتاعك ان الكالسيوم بيديني orange. It's okay. Both are correct. And sodium yellow. Okay, testing or present testing for copper, iron 2 and iron 3 by using sodium hydroxide. As you see, blue precipitate in case of copper. Most of copper salts and precipitate are blue. In case of Fe2, 2 green precipitate, and Fe3 brown precipitate. Okay, I want this table. I want from you to memorize the formula only of the positive ions. Okay, so in your guidebook, page 54 and 55. Okay, and in your student book, as I said to you, our lesson starts in page 191. I want from you testing of gases like this. Testing of water by using anhydrous. Please memorize well. What does it mean by anhydrous and hydrous, and what is the color, and what is the formula, and how I can test the presence of ions by using a flame test to detect the cations or positive ions. These colors and the table in your guidebook. Also testing for cations by using sodium hydroxide give you blue precipitate with copper, make copper hydroxide, and the formula is CuOHO2. And in case of iron 2, it will give me green like this, green precipitate from FeOH2. And in case of iron 3, it will give me brown precipitate from FeOHO3, iron hydroxide. Okay, this table with us and important summarize the lesson. Thank you and best wishes.